Gonna go maximum 1/2 inch. I don't want to get into the gibs. Probably got 3/4 of an inch to go there, to get there, but just taking my time here. See what we can do with this. What I'm mounting is manufacturing some brackets for to put the linear scales on for a 3-way digital readout. There. It's close. All right. Put on the second one here. Yeah, we've got this bracket here, this system, B for the Z. Now I'm manufacturing a bracket that'll handle the transducers for the Z and the linear scale for the Y, and they'll be mounted together. Start here. Nice old 70-year-old castings. Looks like we need to put 3/8 tap in there now. Plug tapping first, and we'll put the bottom tap in next. Ended up with about between a 5/8 and a 3/4 depth. That bottom tap. What's there? What's there? I got the air hose off, so let's just use this thing. Nice hole. We're only going to hold a piece of metal that's going to hold an indicating tool, so there's really no strength required, but we do want stability, so. Oh yeah, we got plenty. Let's see that or not. Plenty of thread, 3/8 deep. Excellent. now we got to design plate here, goes out, goes up here. Amp this out a little bit. Okay, right over here. You just barely see it. There's a hole right here. In that hole, originally, was this little screw. Okay? So, what I've done is I've made two bigger screws. Alright? This screw is going to replace that screw on the left side, and this one is going to replace the identical screw on the right side. Now, once these are in place, I turn these on the lathe. I'm going to that's the left side. There'll be a second one here. Okay, replace this second screw. This plate that's going to mount here will come up and be level with the thread, the back of the threads. I have to thread this end of this rod now. There'll be a plate that goes across here and catches both of these and this plate here. That plate will also extend out here and catch the backside of the linear scale for the z-axis. This will be the scale for the y-axis, and on this end of it there'll be a connection for the transducer that's on the z-axis. So as this moves up and down, it'll give the z reading, and as this moves back and forth, I'll be mounting a bar on here to come down and take the readings on the x-axis, I mean the y-axis. And I still have to drill and tap for the back of this, and that's fine. That won't be a problem. Okay. All right, should be down within 5. Let's see. Actually got about 30 to go. There we are, right on the number. 375. Okay. Now we're going to do some threading. Long ways to go. I don't know if we're going to happen. I don't know. 7. 60, right? Okay. Now this one is for the side that I drilled the 2 holes in. This is for the side that's going to replace the screws, the existing screws on the front side. Now I've got to thread both of these and put square off for a wrench spot on both of them. This end here, I'm gonna counterbore the part that I drilled so that this has a flat surface to mate against. This already has a flat surface to mate against. I didn't show the toolbar back here. I had a Tom Lipton showed a video where he made a back bar for his tools. I took his advice. So I take this out of here. Okay, and on the back side here, I put a piece of the rod there, mounted it on the back of the shield. Then I mounted these things they're like $2 a piece at Home Depot, and I'll show it, some of the little shorts that I'm going to put together. I put these in the mill and just knock the edge off of this so that the tool holders would fit on them. So it actually, 6, 8, I got 8 of them up there now. I got room for a couple, 3 more, but it's kind of neat. Everything is right there handy, and just take them off and post and stick them on there. That's it. Nothing to it. Okay, what we got going now, I drilled and tapped these 2 holes, turned these studs, the threads on this end, this is the bolt stud that I'm replacing this screw with. I was going to do both of them, but I only need one up here for strength. So now I have 3 studded areas. In order, I made a template out of cardboard. For a layout. You'll notice this part of it extends past. I just stuck this scale, linear scale up here so I can start fitting it out. So I use this template to create this. This is a piece of 1/4 inch plate I cut out on the with using the plasma cutter. I probably should have used the bandsaw, but my bandsaw is it's a makeover deal. I did a video on it. You'll see that one of these days too. Okay, I'm going to put a couple of jam nuts behind. Obviously, we're going to have to. There's going to be issues with alignment for everything. So I'm putting jam nuts on here so that I can adjust the placement of the this plate, both from this plane and this plane. That plate is serving 2 purposes. Okay, the jam nuts are in place. This plate, you'll be able to see now the general idea. Okay. This is the transducer here. This transducer moves all the way up and down for the Z-axis. This stick out here on the plate is going to be, I've got a little section of it that sits out. It's going to bolt into this transducer. I haven't taken the shipping plastic off of this transducer yet until I get things fitted up a little bit. I'm going to mount this and this at the same time. Then I'll run it up and down with a dial indicator. Make sure that we've got the right distance, it stays the same all the way up and down. Nothing changes, both from this plane on this one and this plane back to front, so that nothing binds up while it's moving. Now the other point is, we also have to work this plate. The reason for this plate being the way it is it's also going to, this plate is going to hold the y-axis. And I'll bring a piece down here to tie into this transducer, and then as the table moves in and out, it'll move this transducer, and as the knee goes up and down, it'll move this whole area up and down, and it'll move this transducer. So that'll take care of these two axes, the Z and the Y. And then I'm mounting the x-axis directly to the table itself, and that doesn't require any special stuff, no manufacturing. All of this stuff is simply because there's just, no other way to mount digital readouts on the HL. But this is just like a preliminary now. You can see what's going on, and I'll set up. I'm going to set this up and start measuring, making sure we got everything stays in the right plane when it moves. And then as I get closer to the end, we'll do final adjustments on everything. So hopefully this will all work out. Have a great digital readout system on my HL. Alright, here's what we're doing now. I just made this bracket. 1-inch steel. Then I had to weld in a crooked angle here so that it make up for the casting angle, so compensate for that so I can get this angle straight up and down. Now I put the plate on there, and I had a little bit of this end was further in than this end, so I jacked the jam nut out, tightened up the fiber nut again. I'm getting ready to run it back and forth. I'm still trying to figure out what to do with these guys here. I can put some sleeves in here and space them out to here, and then I'll take this off, put a bolt through the back side, through a sleeve, through the hole. I've got these marked. There's 60 centimeters apart, the holes here. This is a total of 80 centimeters. So basically, this is my travel. This is the rear travel right now, where it is. The front travel I've got marked here. So I get the full travel there. The same. Now we've got to mark this. I've marked the back plate, but I haven't determined the run out from top to bottom yet. So I'm working on this one now, figuring where to shim this so that I don't get any bind up from the transducer running across it, either in or out, up or down. So that's what I'm working on now. I'm just trying to, I'm taking some shots of it now so I can study these inside later, but Actually, it's coming along better than I had expected. This is going to be a pretty tight installation. It's going to be good. Everything's just kind of fly by the seat of your pants. I don't have any drawings or anything of it, but you know, you can visualize it, then go ahead and make it, and then make some adjustments. But I've got the full 9-inch travel on the y-axis. I've got the full z-axis travel, and of course there won't be any problem. You can see the daylight through there. That's where the it's all the way back right now, and I really won't lose anything. I think that's about the width of the linear scale for the x-axis, and that just runs straight across without any problems at all. That just bolts right to the back of the table. So right now it's just I've got to punch these holes and determine whether I want to have a solid bolt coming through and locking and then bolting again, or just, you know, might as well just take the whole thing off, get the shims right, then assemble it off, and then put the just come back, have this part assembled already to the scale, and then I just have to come in and put the 2 bolts on the ends of the scale, and these 2 bolts I drilled and tapped up here for the transducer bracket. So yeah, I just took some 1-inch, cut it into pieces and welded it together, and then I added a couple of pieces, one on each side, so I could get my 80 centimeters out there. And of course this plate here, it already has, it's all set. All I have to do is shim it and determine, make sure I don't have to, I may have to bring the bottom out or in, or the top in or out, or whatever. Alright.